Telco AI deep dive. Obviously, we want NVIDIA at the table anytime we're having a conversation about AI. But maybe to start, you can tell us a little bit about the company's telecom business. I guess specifically trying to understand how your accelerated compute portfolio fits into the world of mobile networks.
Yeah, great question. So as you said, there is a moment of AI. We obviously think that this moment is going to live for a long time, multiple generations. How did we come to this moment? I just recap on that briefly. Is that accelerated compute, and in our case, the use of GPUs and DPUs to accelerate compute has really enabled us to hit this moment of AI, because AI requires a large amount of compute. Few thousand X over the last few years has been as a result, in terms of compute performance, has been as a result of acceleration. Now, on the telecom network is also going through transformation. One is the virtualization of functions that have normally been driven by proprietary equipment and specific single-purpose equipment. The other is the incorporation of new capabilities within the 5G standards. And so if you look at things like latency, obviously disaggregation from the hardware and software, and then ability to maintain certain throughputs, performance, spectral efficiencies, all of these are coming together at this moment in time, and many of them can benefit not just from AI, but also from the benefit of accelerated compute. Just the baseband compute acceleration, layer one being 70% of, say, the compute workload, can really benefit from the accelerated compute. So virtualization of the network, meaning use of software-defined capabilities on standard hardware. Think of accelerated compute as standard hardware. The 5G standards, and the 5G standards mean that now new applications can take advantage of the new features in 5G. These things are coming together at a perfect moment in time.
You mentioned a few of these big trends operators are investing in through the ongoing evolution of 5G, a lot of virtualization, a lot of move to the hybrid cloud, distribution of the cloud out to the edge of the network or even onto customers' premises. But big picture, where does AI fit in here? How can AI help operators deliver a better network to their customers? And then how can it help them better monetize their network by providing those customers new services?
Right. So it's almost like, where wouldn't you use AI? Maybe I don't. That would be a question, because AI is starting to find its way into multiple different areas for the telecom network operators, both for internal use and obviously for customer use. If you just took a few examples, let's take, for instance, customer experience. Customer experience of the telco customers, and in this case, think of the traditional customer base, meaning the consumers. Right? Whether you're calling in to a telco to change elements of your service, report faults, whatever it may be, the traditional method has always been call a customer service call center. Call centers are now being automated with AI. You can experience a different class of service using AI, understanding the background of your call, but also the background of you as a user. And so telcos are already engaging in, whether it be text optimization, avatars, voice recognition, multiple languages. This is something that's going to be a really fertile ground, customer service improvement. In terms of just focusing on one thing that we announced previously, say with AT&T, is the ability to optimize technician callouts, using the ability to accelerate and use AI on rerouting technicians. So it can be done real time, not on an overnight basis, and can be done real time in an efficient cloud implementation. Network operations lend themselves to AI in terms of the amount of data that's being collected. And as large language models improve and large language models guidelines become more factored for single-use optimization, a language model of network operations, for instance, can now be leveraged as well. So I've just touched briefly on a few examples because we don't have time to go through all of them. But these are transformative and I think AT&T said in their earnings call how we're working with them on helping them to optimize their operations. But that's just touching on just a few examples.
Can you take us through the details of your announcement with SoftBank? I guess tell us a little bit about the tech that's involved. Tell us what this does in terms of enabling SoftBank to run AI workloads alongside their network. And then tell us what it means in terms of the actual 5G RAN.
Yeah, so firstly, the tech has been a few years in coming. So our goal has always been to create a software-defined infrastructure. Easily said, hard to do when you think about RAN, for instance. Many other functions like 5G core, UPF, etc., have already moved to virtualization, as well as other VNFs or CNFs within a telco cloud. The move RAN, which is a timing sensitive, timing synchronized, but also heavy compute workload with high degree of resiliency and robustness to a software-defined workload, has always been a challenge. Performance has been not really equivalent to where we've seen some of the more single purpose. And so single purpose accelerators have been built for, say, layer one to enable that to happen. We didn't want to use single purpose equipment anywhere. So we've been able to use our acceleration, compute acceleration, to enable us to get to, and actually, in some cases, improve upon single purpose equipment for the RAN network. Point number one. By using that software-defined capability within standard hardware, you can now run that hardware in a cloud, not just a telco cloud, but also, and think of it as an IT or applications cloud. So that's point number two. Now you can load share, and you can between AI workloads, between and telco RAN. So think of it, remember, RAN equipment infrastructure is probably a 25% utilized equipment infrastructure. So you continuously over provision. And even with the over provisioning, you're never really, even with peak use, you're never quite really getting to that point. Now you can balance this workload, RAN and other workloads on the same infrastructure. Opens up a plethora of new opportunities, both for the telcos, but also for the customers that may want to use the telcos as a regional cloud, for instance. So the other point on the tech that I would mention is that as you go through software-defined optimizations over time, you get more and more improvement and more flexibility of delivery and deployment. So you may be wanting to run FDD, TDD on the same infrastructure, run different frequency bands on the same infrastructure. All of that can be done, massive MIMO, millimeter wave, 44R. All of this can be done just by software updates now. No need for new silicon, new hardware, etc. So we've really now hit the performance metrics, we've hit the multiple use infrastructure metrics, and hit the software-defined metrics that enable this to happen. So you asked a question about what does that do in terms of opening up new opportunities. You asked earlier about MEC. MEC has been talked about for a long time. Hasn't really provided a new opening of new opportunities up until now. Large language models have changed that. LLM inference at the edge is a very viable business model for whoever owns that infrastructure. You can now sell that infrastructure and you can leverage that infrastructure. This is the first time that you can really do that for a very prolific application. Everyone's looking for the killer app on the MEC. This now gives you an application that is broadly used and highly valued. And that same infrastructure can also run RAN. So that's now the heart of what we're doing with SoftBank.
So, a lot of opportunities here for operators to really leverage AI to better monetize the network, to better manage the network. And, I do want to talk about the other side of that and hear from you about maybe the challenges that are coming up in your engagements with customers, with potential customers, any kind of feedback around things like price, performance, power consumption, and then maybe even the organizational ability to execute in this new technological paradigm?
Yeah. So, the three Ps that you mentioned earlier um, haven't been, as you might be surprised, haven't been a bigger factor. Let me justify why I make that bold claim, because that's always been a point when thinking about network infrastructure, particularly when it's DRAN and DU at the cell site. It's because the infrastructure has been single purpose. Now, if you think about what I said earlier, that infrastructure is probably 25% on average utilized. It's a large investment, even at the pricing of network infrastructure. It's a large investment for a relatively poor return on ARPU for consumer use. The whole game has now shifted towards an infrastructure that can be used for multiple different applications, AI being one, and LLM inference, for instance, being another. AI is making its way into, as we mentioned earlier, the telecom operations, was making its way into the new capabilities that will be run based on LLM for enterprise use or for consumer use. You can also, as a maybe it's the operator, maybe it's an operator leveraging their customer contacts, enterprise contacts with a cloud service provider or a hyperscale provider. You can also now sell access to the GPUs. Right? Just that alone changes that equation of price. I mentioned performance earlier. The performance of now using accelerated infrastructure has overtaken really where we see some of the ASIC-based infrastructure being. And the cycle of improvement of software and the flexibility of improvement and deployment now becomes, as I said, software defined, becomes dependent upon software definition, not dependent upon hardware creation. In terms of power consumption, we really now get to the throughput question, which is what's the watts cells per watt that one can support, or gigabits per second, gigabits per watt. The throughput that you can achieve, which admittedly is mostly when you're thinking about CRAN, but also as you start to look at aggregation of cell sites, even at a single site. We get 36 gigabit per second downlink throughput on a 1U server with our Grace Hopper architecture, right? Take that to a 2U server, you're now 76 gigabits per second throughput, 74 gigabits per second of throughput. It changes the equation dramatically on power, price, and performance. And the last question I forgot is your break on your alliteration.
Yes, that last part of the question was around the organization, how operators are investing in people and processes that'll let them make the highest and best use of these new capabilities.
Yeah, so we're starting to see, not all operators around the world are created equal in terms of where they're at in their ability to monetize the infrastructure that they have, cloud infrastructure. We're already seeing some operators around the world are the regional cloud providers within those regions. And as you start to see requirements for data privacy, for a GDPR, data sovereignty, for even enterprise data to remain on-prem, we're starting to see telcos playing a role in that conversation and that role in that ecosystem. So already we're starting to see telcos that have gone through that learning on how to drive a car, and there'll be many others that can do that because they need that monetization uplift for the infrastructure investment.
So, what's next for NVIDIA in the telecom space? What are you thinking about in terms of big opportunities, both longer term and shorter term?
Yeah, so we tend to always take a long-term view, and then we can work back from the long-term view. Let me just take a long-term view for a second. I'll come back to what you said in terms of the shorter term. I think it's indisputable now that the next generation, with whatever the term of the next generation of wireless standards may be, is going to have to leverage AI in the signal processing. We're running out of spectrum. The spectral efficiency, whether it be traffic models for uplink, downlink, whether it be weights for beam forming, whether it be the ability to provide AI in the RAN intelligent controller or the operational aspect of the RAN controller, all are going to require AI. And there's many other capabilities of on the physical layer as well. The ability to provide link layer simulations and then break that link layer down into component parts, as opposed to end-to-end simulation of the physical layer. All of these things require AI. And as we work back, having a GPU in the system, having accelerated compute in the system, allows you to dynamically, just the environment that the network has to operate in changes dynamically, adapting data collection, pushing that data back into channel equalization and channel estimation, putting that data back through IQ samples, and real-time adjusting using pre-trained AI models. That's another reason that we see AI is essential in this, let's call it AI within RAN. And so work your way back, that requires GPUs. Same time, the same GPU can be used, the same accelerated compute can be used to offer some of these services like large language models training and the applications like computer vision. Perhaps the first application using AI that has been really started to hit resonance and pick up is intelligent video analytics. That's going to become even more in demand as we start to see more autonomous analytics at the edge. You don't want to push all that data back into the network, into the cloud. You want to use it at the edge, aggregate and do the analytics at the edge, do the inference at the edge. So these are the kinds of things that we see happening on the long term, and they're all pushing back into that short-term time frame that you mentioned.
All right, Ronnie, really great to catch up with you, and I appreciate you taking the time to join our Telco AI Deep Dive.